we see that we get 0 in the denominator, so that won't work. So what we're going to do is we're going to see what it means for it to go from the plus. We know when it comes from plus, it's coming from this side, it's coming from a number that's bigger than 5. So it's going to approach the 5. And so it's going to come from this. It's going to be like 5.01, then it's going to be 5.001, 0.00001, all the way from 5, but as long as it's bigger. So we have to kind of like think about what happens if we plug in this kind of number into here. So if we plug it in, the numerator will just stay the same, right? 6. But the denominator is getting infinitely, it's all like, we can say that it's always going to be bigger than 5. So since it's always getting bigger than 5, the numerator is just going to be like 5.000001 subtracted from 5. So what are we left with? 0.000001. And this number right here, the subtraction of the two, this number will just get even smaller and even smaller. So if we have a number like 0.001 here, right? And it's just getting even smaller, even smaller, even smaller, right? Say we plug in a number into 6, like this. And let's say we plug in, 10. That's decently, that's like kind of small. But what if we just plug in 1? It got bigger, right? What if we plug in 0.1? It gets even bigger. What if we put 0.01? Even bigger. This is huge, right? Because it will go so many times. Even bigger. Even bigger. Even bigger. Even bigger. So it turns out that as the denominator keeps on getting bigger, as this guy keeps on getting, keeps on getting smaller, the overall fraction keeps on getting bigger. And so as this gets even smaller, this entire fraction will get closer to infinity. Okay? So that's actually going to be our limit. As the 5 gets closer and closer from the right side to 5, the limit is actually going to be infinity. So we have another example here. When we plug in 0, we get a 0 in the denominator. When we plug in 0, we get -1, and we get 0 times 2. And this will just basically become -1/0. And this is undefined, so we cannot have this. So what do we do in this scenario? What we're going to do is first we're going to see if it's continuous. So we're going to plug in from the left and from the right. And let's see if we get anything. So when we do that, this is another technique that we use. When we see that it's undefined, what we're going to do is we're going to plug in from the right and we're going to plug in from the left. And we're going to see if it's continuous. So let's just see what I mean. I'm going to show you. So 0 coming from the right for this rational expression, and we're going to have 0 coming from the left. Okay, we're going to do this one at a time. So x squared and x plus 2. So 0 coming from the left, from the right. So let's draw the number line, and we have 0 here, and this is the positive sign. So as it's bigger than 0, but it's getting very close to 0. An example of this is like 0.01, and then 0.01, 001, 01, 01. So that's our number. It's keep on getting more zeros. It's getting so much smaller, but it's never going to get to 0. It's just getting super close to 0, and it's always going to be above 0. So what happens if we plug in that kind of number here? Well, the 2 basically will stay the same, right? If we plug in like 0.0000001 into there, this basically stays 2. This will basically become -1. This one will stay 2. But what about this guy? This guy, he will become, when we plug in this number and we square it, right? It's just basically getting even smaller, even smaller, even smaller. And because we have such a tiny number in here, 0.0001, right? The overall denominator is going to become super, super small. So what happens when we have -1 over a super, super small number, 0.00001? Well, like in the last example, when we had a number 1, and we put 0.1, and then we put 0.1, 0.1, as the denominator kept on getting smaller and smaller, the overall fraction got super, super big. And so it turns out that it will also approach infinity. But we have to keep a note of the negative sign in the top. Because of this negative sign, we're like dividing a negative by a positive, so it's like going to be like negative 1 over infinity. This is going to become negative infinity. Negative infinity. So the limit from the right side is negative infinity. Okay, let's see if it will be the same for the left side. So I'm going to erase the right side. We just know that the right side, it's negative infinity. What about the left side? Well, in the number line, if 0 is here and we're coming from the left side, that means we're never going to get to 0, but we're getting very, very close to 0, and we're always going to be we're going to be negative. We're always going to be a little bit less than 0. So how would that look like? That would be like 0.1. That's less than 0, and it's get very close to 0. Then we have 0.01, 0.0001. So it keeps on getting very, very close to 0, but it's always negative, and it's always less than 0. What happens if we plug in that kind of number into there? Well, let's see. When we plug it into here, this basically stays negative 1. This also stays 2, right? But what happens when we plug into x squared? This guy squared is basically the same thing, except it's going to become a positive sign. 0.000001, right? So when we plug in again, 0.00001, this overall denominator is going to get so small, and the overall fraction is going to get overall so big, because this is going to become like this. Negative 1 over infinity, and in the last, when we did this one, we also said that it's just negative infinity. So since the limit from the right side and the left side is the same, we can say that the overall limit for this problem is just going to become negative infinity. I hope this helped.